Welcome to section 6.6 on variation. Alright, so in variation, we have a certain variable that we call the constant of variation, and that would be k. This is talking about how things vary with one another. So for an example on what variation might be, if we have direct variation, so this is one way we can have a variation. We'll have some variable, which is going to be equal to, and we have our constant of variation k, and then our other variable, for example, maybe x. And we would say here that y varies, so y varies directly with x. What would this mean? What's an example? Well, let's just say maybe the more you study, so studying goes up, the higher your grade goes up, right? They directly grow together. Okay? Or maybe the less you study, the lower your grade gets. Okay, so those two would be considered direct variation. And now another one we have is called inverse variation. Maybe they don't grow together or they don't drop together. This would be, for example, y equals, and we always have our constant k of variation, 1 over x. So the reciprocal. Now an example of this might be, the more you work out, the less you weigh. Right? Maybe you lose weight. Or maybe the less you work out, the more you weigh. A simple example, but that's a concept. One of them grows and the other one drops. Or maybe the more you spend, the less money you have, and so on. Just an example of inverse variation. And now we have something called joint variation, because sometimes in life things aren't quite so simple. So maybe you'll have something like y varies directly with x, but inversely with z. So maybe an example would be, the more children you have, the more fun you have, the less money you have. I don't know. That's just an example. So these are all very simple examples. But those are an example of variation and how we would end up using them. Direct, inverse, and joint. So now, steps for solving variation problems. The book might have slightly different steps, but these are the steps that I'm going to look for in your work. So make sure when you're solving, especially on the exam, that you show these steps and you label these steps. So the first step would be the general formula. And this is when you just build the formula from the word problem. So for example, this is when you still have k. So you still have k unsolved for. And please note in your work, make sure to label general formula. And then after that, we'll read through the word problem and you'll find items that help you solve for the specific formula. And that is the formula where you find out what number k is. So you've solved for k. And then lastly, it's the application. Now you use your specific formula to solve. Okay, those are the 3 steps. Make sure to label them in your work just like I ask you to label your x-intercepts and so on. General formula, specific formula, and then the application. So let's take a look at an example. Example 1. Suppose y varies directly as the square of x and y equals 200 when x equals 5. Find y when x equals 7. Now there's a ton of work that goes on, or a ton of wording that goes on here. Not necessarily a ton of work. And what I like to say is most of the time it follows a certain pattern, these problems. So usually it says, suppose y, and then we see our keyword. Do you see the keyword? Varies, because we're talking about variation problems. This first sort of sentence or statement is where we find our general formula from. And then it says, and y equals 200 when x equals 5. It gives you a grouping of information for your other variables. That would be your specific formula. And then lastly, it tells you to do something. It says find, or it says figure out, or something. It's telling you what to do. When it tells you what to do, that's your application. And usually, it follows this sentence structure in the variation problems. The first one helps you find your formula. Second one helps find the specific. And the third statement, or question, or maybe in this case, command, tells you to find the application. So let's take a look and see if this works. General formula, that's my first step. I want to build an equation that's a variation equation. And it says, suppose y, varies directly as the square of x. So whenever I see y varies, immediately I'll put down that variable, and then I go k. Why? Because varies is talking about the constant of variation. So you always plop in k when you see the word varies. And it's talking about directly, so it's not inversely, as the square of x. So that's going to be x squared. And there we have it, our general formula. Not too bad. Let's go ahead and find the specific formula. How do we find the specific formula? Well, remember, the specific formula is when we have found k. In order to solve for k, we need to have a number for y and a number for x, right? Because then we can solve for k. And that's where this second sort of part of the sentence comes in handy. It gives me a number for y, which remember I needed, and a number for x, which remember I needed. So I can plug those in and solve for k. So y equals kx squared. We're going to plug in 200 for y and 5 for x. And then solving, we have 200 equals 25k. Solving for k, we have k. Alright, so let's go ahead and divide both sides by 25. Okay, let's see. If you have $2, how many quarters is that going to be? That's going to be 8 quarters, right? There we go. 200 divided by 25 will be k. So we found k, which means my specific formula is going to be y equals, now we're replacing k with 25, or sorry, with 8x squared. Now we have an equation that is specific to my kind of problems, and we found our constant of variation. So now we can actually use it to solve our problem. So our application. And that's where we have the end goal here. Find y when x equals 7. So let's see, we're told to find out what y equals when x is 7. And we can solve for y. Let's do that. So y times 8, we're replacing x with 7. So y equals 8 times, so 7 would be 49 when it's squared. And then doing out the multiplication, we have, so 72, 8 times 4 is going to be, and 32 plus 7, so 32, 7, 8, 9, so 39, 392. Y is going to equal 392. And once again, this is a word problem, so let's go ahead and write our answer. When y is, when x is 32, so when x is, not 32, 7. When x is 7, what do we know? Y is 392, period. Alright. Okay, let's take a look at the next example. P varies jointly as q in the square of r. And p equals 200 when q equals 2 and r equals 3. Find p when q equals 5 and r equals 2. So spend a moment, see if you can break this sentence up into those 3 different versions that I mentioned above. See if you can find the one that talks about finding our general, and the specific, and finally our application. Okay, so let me see which colors I was using. I was using yellow, blue, green. All right. So P varies jointly as Q in the square of R. That tells me how to find my general. It's talking about variation, and then all the little things like jointly and so on. Next, we're talking about actual values for our numbers. So P equals 200 when Q equals 2 and R equals 3. That's the next section. That will give me my specific formula. And lastly, it tells me what to do. It says find P when Q equals 5 and R equals 2. And there we go. We have it sectioned out and ready to go. Let's go ahead and do our general. Once again, the general formula is where we have K, but we don't actually have a value for it. So it says P varies jointly, which means we have multiple things coming later. So P varies, and immediately when I hear varies, I do the equals K. So that's a part some students forget. Make sure to remember that. Varies, you're right, equals k. Jointly as q, well, just means that q is multiplied there. And then the square of r. And there we go. That's it for the general formula. Now we need the specific formula. This is when we find k, which means I need to be given values for p, q, and r. And I'm given that. I'm given p, q, and r, so we can find k. So p is supposed to be 200, k we're solving for, q is supposed to be 2, and r is supposed to be 3. So we have 200 equals k, so 2 times, that's going to be 2 times 9, 18. Divide everything by 18. Let's see. I don't believe that's going to be evenly dividing. So let's go ahead and simplify. 18 divided by 2 is going to be 9, and 200 divided by 2 would be 100. Yeah, that's not going to simplify. So I'm just going to go ahead and leave it as 100 over 9 for now equals k. And there we go. Let's go ahead and build up our specific formula. P equals, we have found k now, 100 over 9 qr squared. And there we go. Our specific formula. Now let's do our application. This means we're going to be given values for every variable except one of them. We're going to have to solve for one. What are we given? We're told to find p. Okay, so we're going to try find p when q is 5 and r is 2. So q and r are given. All right, let's go ahead and solve. P is going to equal 100 divided by 9 times q, which is 5, and r, which is 2 squared. All right, so we have 100 divided by 9 times 5 times 4. So p is going to equal, 5 times 4 is 20, so it's going to be 2,000 divided by 9. And that is not really going to simplify, so we can go ahead and just leave it as that since it's a simplified fraction. So the answer would be when q is 5 and r is 2, p is 2,000 divided by 9, period. As long as your fraction is completely simplified, you can leave it as a fraction. All right. And let's take a look at the last example. Example 3. For an object falling freely from rest, disregarding air resistance, so it's a simplified problem, the distance the body falls varies directly as the square of time. So we're talking about, let's say, there's some tall object, right, like a building or a structure. Something falls off. We're talking about the distance that it falls, so this distance varies directly as the square of time. If an object is dropped on the top of a tower, 576 feet high, and hits the ground in 6 seconds, how far did it fall in the first 4 seconds? So once again, now this problem is a little larger, but try to take a moment and see if you can figure out how to break this up into those 3 little sections I talked about. Okay, so let's see. The distance the body falls varies. Ooh, I have found that keyword, varies. I know this is going to be for my general. So this part all will here be part of my general formula. We have the word varies. Next, it says, if an object is dropped from the top of a tower 576 feet high, and hits the ground in 6 seconds, how far did it fall? Okay, so we're first told some items, and then we're finally told to find an answer. So those are my 3 sections. So let's go ahead and apply that. So general formula. That's where we just build our formula with our variation. So it says the distance the body falls varies directly as a square of time. Oh, I just realized something. We aren't given the variables. So it's fun in some ways because we have the ability to create our own variables, but we also have to make sure to state them. So let's go ahead and state them. We have 2 things. We have the distance the body falls and the square of time. So I'm going to say let t equal time and d equal the distance the body falls. And once again, you just create a let statement if you're not given the actual variables, which we weren't given. So d varies directly as the square of time, which means that d varies. Once again, once we see varies, we write down equals k, because that's our constant of variation. And then as the square of time. So that's just going to be t squared. And there we go. That's our general formula. So now, what do we need to find? Our specific formula. Okay, that's when we find k, which means we need to be given values for the other variables. So we need to be given something for d and t. And we are given something for d and t. Let me go ahead and highlight them. We're told if the tower is 576 high and hits the ground in 6 seconds. So that's the distance it fell from. We had a tower that was 576 feet. And when the object fell the first time we tried it, boop, it took 6 seconds. So that will help me build my specific formula to find my variation. So d equals kt squared, and d we are told was 576, and k, and then t was 6. So let's go ahead and solve for k, our constant. So let's see, so 576 equals k times 36. Dividing both by 36. And for now, I'm going to go ahead and leave k as this. I don't need to fully simplify this because it's still not the end of my problem. So my specific formula is going to be d equals 576 over 36k. One thing to note, if this doesn't simplify fully, please leave it as the fraction. Only round at the very end of your problems, so keep that in mind. Only round at the very end of problems. Okay, so that's supposed to be a t, actually. Sorry, not a k. That's supposed to be t squared. All right, what else do we need to do? We need to solve for an actual application. So this one is saying, how far did it fall in the first 4 seconds? So it wants to know how far the object fell in 4 seconds. All right, let's go ahead and solve that. So here's my application. Once again, label your work, please. We want to know how far. So far is talking about the distance, right? So we're trying to find the distance when the time is 4 seconds. So let's go ahead and solve that. So d is going to equal, and we have our k, 576 over 36, times our t, which is 4. So d is going to equal 576 over 36 times, and that will be 16. All right, so can we simplify this? Well, I know 36 divided by 4 is 9. 16 divided by 4 is 4. And then we have d equals. Now let's see. So I'm going to first try to see if I can simplify 576 with 9. Let's do a many division problem on this side. How many times can 9 go into 57? Well, I know that 9 times 6 is 54. So it's going to be 3 left over, and 36. Ooh, 9 times 4 is 36. Hey, look at that. And so 9 goes perfectly into 576. So I can go ahead and simplify the 9, 1 left over, and the 576 is going to be 64. So d is going to equal 64 times 4. Doing that on the side real quick. 64 times 4, that's going to be 1625. So 256. All right, and then there we go. So we have 64 times 6, or 4 was 256. And are we done? Really close. We still need to write our answer in word form. So it says, how far did it fall in the first 4 seconds? It fell 256 feet. The object, so once again, don't just write it. Be specific. The object fell 256, what? 256 feet. In what? In 4 seconds. So make sure the sentence is specific to your problem. All right, and that is it. Once again, for any of these problems, if you have any questions about the problems or any of your homework problems, please send me an email or pop by the office hours. I'll be glad to help.